Imagine you wake up and one morning you start feeling sick. Your skin starts to produce these brown spots as well, and then naturally you go online and you look up the symptoms where you discover it to be a form of either flu or some form of cancer. Which explanation would you believe? The answer is most important as it can be the difference between you going back to the bed or literally ending up in the hospital. In a situation like this, you are no longer just weighing an individual piece of evidence as you do with probabilistic thinking, but now you decide between two overall explanations of the evidence you have at the current point of time. To be able to solve this issue, you can use a mental model known as Occam's Razor. The idea behind Occam's Razor is that given two explanations seem to state facts that are equally, it is always best to go with the simple explanation, as that is more likely to be true. It makes sense as well because I remember when I was doing maths in high school, my teacher would tell me that whenever you're solving a problem and your solution starts to become long and very complex to the point that you don't even know what's going on, then you've definitely done something wrong, as most of the time the answer is actually most likely simple. That's because the more complicated explanation has more variables that need to be true than the simpler ones. And with each additional variable, the explanation becomes less likely to be true. For example, say your best friend didn't show up at your birthday party, and you haven't heard from him for such a long time. So you start to consider the scenarios. Maybe he got in an accident, but that would require so many variables to be true. Did he leave his house? Did he drive a car instead of walking or taking public transport? Did he have someone drop him or an Uber ride? Did he or another driver make an error in that case? And did that error lead to an accident? The answer for all of these questions need to be yes for the explanation to be true as well. There's a simpler and more likely explanation that he might be just running late, and maybe because he just forgot to look at the time or he's just due to traffic. Sometimes many variables do line up, and unlikely things like car accidents can happen as a result. So none of this is to say that your friend crashing is impossible, but the point is that simple explanations tend to be more true than the complex ones. Hence, simple explanations is therefore the most safe bet when two equal factual responses are presented. So going back to the question, there would need to be a lot of factors to be true if you had cancer. And so the response with the flu is more simpler and a probable explanation. And this is the mentality that you should start to embrace. Because we can have so many situations and scenarios that happen, and we can have so many explanations towards things, and we give ourselves false evidence and believe in that and waste our time stressing, giving energy into that when we only considered one mere variable amongst the 10,000s of others probably variables that need to be true for that explanation to be reality. So an action step that I recommend is, if you're ever hesitating between two choices which have equal facts, then use Occam's Razor to shave off the most complicated explanation and go with the simplest first, and then you can start to investigate. And let me give you more of a scenario to paint the picture a lot better. For instance, imagine you're a manager at a software company, and your team is facing performance issues with a new software application. Now, many of you might not be in the software realm, but this is applicable across any industry, any issue that you face. So I'm just giving the example of a software so you can visualize it. So users have apparently reported that there's slow loading times, and you need to investigate the root cause of the issue. First, you would define the problem, which is the slow performance on software applications. Then you want to list all the different causes that could have occurred or evaluations. So the first one can be something as simple as something like the server hosting the application is overloaded due to high traffic. The second one is the software code has inefficiencies leading to slow execution. The third is a bug in the backend servers that cause delays. And the last one can be something like network latency from the servers or the client side, which causes delays. Then you have to evaluate the simplicity of each of these, and then you can actually see that the hypothesis number 2 is the most simplest compared to 1, 3, and 4, as you have to consider a lot of external factors that need to be true for it to occur. So maybe it's worth investing your time or investigating your time into number 2. So you reach out to the team who manages the software code for this application and see if they can identify any inefficiencies that can either fix this issue or optimize the performance. Also note that just because you went with number 2 doesn't rule out the probability of the others. You should just start with the most obvious and simplest answer and go from there. Because imagine you start with the most complex one, like number 3 or 4. You would have to invest so much money, energy, and time, and then you find out that it's not even true. Then you have to invest even more energy and time. Whereas if you went with the simplest and that ended up becoming solving the issue, then you would have had to invest a lot less energy and time into solving the problem. So after you go with number 2, then you can start to conduct tests and refine and go with the next easiest option. And based on your findings, you can do reviews and profile and improve the performance of the software. So you can see how Occam's Razor can resolve very complex issues, and it can streamline your investigation and decision making as well, which makes it a lot more efficient and more focused on the likely solution to the cause of the problem. So if you enjoyed this video, then like and subscribe and stay tuned for the next part.